welcome back to the hyperbolic coding chamber. We are back once again. It is late. We are burning the midnight oil, but dinner is still on the menu, and what we're having is a beautiful 5 or 4 phase course by the incredible chefs over at LeetCode.com. So we know that what we're going to be having is going to be a scrumptious knowledge extraction session. But fortunately, we have quite a bit of time to stall before we get to the main course with some comments. So the comments that we have today are, hey man, are you using Vim key bindings in LeetCode or something, or how are you doing the pure keyboard text editing? Vim is king. You know this. I am using the Vim key bindings in LC. Yeah, I think they're using Monaco, and it has like a built-in support for Vim, which is pretty cool. I don't really use any special. There's like a whole culture. There's a whole culture around Vim and Emacs and like all the different plugins and stuff like that. I don't use any of that stuff. The only thing I do is remap escape to JJ sometimes, but I don't do that all the time. But yeah, I think I always try to keep the simple as possible so that any Vim setup I use is always going to be intuitive. But I know there's a lot of people who go really deep into it, and more power to them. But yeah, it's definitely gotten to the point where I can't use a text editor if it doesn't have Vim support. So it's very frustrating. But it's hard to go back after Vimming. And then we have ADC, legendary skateboarder, part-time entrepreneur, evangelist, philanthropist, and also differential creator in the LC space. I like the videos because the reading comments tradition is fun. It allows me to watch videos I missed on my own time. Okay, respect. So yeah, that's definitely something I'd like to keep. So maybe we can do that. I think if we ever got to a point where we could stream. If we ever got to a point where we could stream for the entirety of the day, that would be ideal, because at least we wouldn't be working. We'd be working on something like game dev or LC or both. That would be ideal. But I still think we'd do the regular video like as normal, and then I would just stream as well later in the day. So I think that'd be the best way to go about it, so that we keep all the aspects, because why throw it away? So I think that'd be pretty cool. I'm now on break, so I think we're about to kick it into gear 1. We're about to go gear 4th, Luffy style, on the projects, mostly the keyboard game, and hopefully we can get something cool coming out of that. I played a lot of Vampires. Actually, I'll say that for the game dev video, but yeah, I'm playing a lot of, not games, but doing some research on the mobile market. It's interesting how things are changing, so we're gonna have to do some extra work to figure out how to break into the space. But that being said, what we don't have to think about or figure out is when it comes to LeetCode, because we just have to show up and do the problems. So that is what we're going to do. I've been cutting a lot of corners recently in the time, even though it's 12:39 a.m. By the time we finish, it's going to be 1 a.m. If we do another hour, it's going to be 3 a.m. After 2 long sessions like that, it's going to be hard to sleep. Intense focus messes up sleep, because now my brain is turned on. Yeah, late sessions are not flames. Maybe we'll do 30 minutes of both, so that we don't end up doing something crazy. So I'd like to kick off tomorrow and just go balls to the walls. So that would be ideal. So maybe we'll start with 30, and then we'll return to everything being normal tomorrow, when I'll finally be on break, so we can finally go normal. Also, one of man's greatest sins is sparkling water, so unfortunately that's what we're drinking today. So I'm going to jump into the LC, and hopefully we can find some relief in the madness. I think what we've been seeing we now have 260 problems done, so we're still making progress. I've gotten, for some reason recently, I've been looking a lot into how much the problem count changes every day, and that's probably a bad habit because now I'm getting sucked into making sure that it's always how do I say? I'm getting sucked into making sure that the number is always trying to get that feeling that we've made so much progress. So I think I just gotta focus on doing more problems and not so much look at this too much. Otherwise, I'll start to get frustrated that I'm not moving quick enough. That being the case, we solved a lot of problems yesterday, so I'll close this one. And I'll close, I think we didn't solve this one yet, so we'll start with these. You're given a 0 indexed, actually let me restart the timer. You're given a 0 indexed string array words. Your word sub I consists of lowercase English letters. In one operation, select any index I, such that I is a valid index in words, and word sub I minus 1 and word sub I are anagrams. And delete word sub I from words. Can you perform this operation as long as you can select an index that satisfies the conditions? I think you could do this in linear time, or we'll start at index 1 and check if index 0 and index 1 are both anagrams. If they are, then we should delete word sub I, which would be Baba, right? And then we won't increment, we'll only increment if they're not anagrams. So we'd go back and say, okay, is Abba and Baba anagrams? They are, so we delete BBA. We should end up with, we'd see CD and ABBA are not anagrams. Then we'd increment one index. And then we'd see that CD and CD are anagrams. So we would delete them. We should just be left with ABBA and CD, I think. Right, so I think this would work. So I think we said let I equal 1, right? I is less than words dot length, I plus plus, and we're actually going to change this to be a while loop just because it kind of has to be so we can control when we increment. And we're gonna say let I equal 0, right? And we'll say if is anagram, right? Words sub I minus 1, right? And words sub I, we'll say it's not an anagram, right? Then we'll do I plus equal 1. But if they are, and it might be easier to just do this, if they are an anagram, right, do the work. Otherwise, right, we want to remove word sub I, so maybe we'll just say word sub I equals an empty string. So the first thing we'll make certain is you have to check if does an empty string count as an anagram. I don't think so. The only thing I have to do is just check that I minus 1 does not equal an empty string, and word sub I does not equal an empty string. We need to actually remove it, or otherwise when we check behind us. So maybe we'll just literally run the splice function. So let's do that instead. We'll just do words dot splice. At index I, we'd like to delete one index. And this should actually modify the array. We can return words, and I think we just need to make the is anagram function, which will take word 1, which will be a string, and word 2, which will also be a string, and return a boolean. First thing we can check is if word 1 dot length does not equal word 2 dot length, right? Then we want to return false because they're not anagrams. Otherwise, we're going to return true, and then what we're going to do is just iterate through the first word, and we're just going to say if the letters ever aren't this. Actually, we could sort them. We can't actually compare letters because we have to sort the words first. We don't want to sort the words because we can do better just by checking one, just by loading the characters into a map. String to number. You can just say for const letter of word 1. Right, we'll say value is equal to if the map has value for the letter, right, then it should get it. Otherwise, it should set it to 0. And then we can say map dot set letter to value plus 1. From here, we can just say for every letter of word 2, right, we're just going to say if. I guess we'd have to load a map of both of them in. So this should tell us if something is an anagram because we're going to load both of them into a map. And if the occurrences don't match, right, then we're going to return false. If we never find a false case, then we're going to return true. So if it's an anagram, right, Baba and Abba, which they are, we should remove Baba, right, and we're not going to move forward at all, right? Then we're going to check again with BBA and Abba. Are they a anagram? And they are, so we're going to remove BBA. Then we're going to check CD and ABBA, they're not, so we're going to do I plus equal 1. Then we're going to check CD and CD, they are. Anagrams, will move in the one at I, and then we'll do I plus 1. And then we should stop. Oh, I forgot it's supposed to start at index 1. Interesting. I would say that the time complexity for us to run is anagram. They're going to do the operations that are based on the number of characters in every word. So I feel like the runtime complexity of this is going to be O of S, where S is the sum of all the characters in the string. And we might do 2S, but I think that's fine. I'd be O of S with constant space, because the map only ever creates space in both of them with 26 indices. But I think you could also sort the strings too, but I don't know if that ends up being any faster. It feels kind of sus. So we'll take that one. Let's try partition array into 3 parts with equal sum. Given an array of integers r, return true if we can partition the array into 3 non-empty parts with equal sums. I see, so 0, 2, 1 plus -6, 6 with equal sums, so -6 plus 6 plus -7, 9 plus 1. If we have to partition the array into 3 non-empty pairs with equal sums, the maximum size a sum can be, non-empty pairs, the maximum size a sum can be is r dot length minus 2. Because let's just say every single number summed together would equal some amount, and the last 2 numbers would comprise the last 3 parts of the non-empty parts. The non-empty parts. This is a little Sussington. How would one go about this? We have 0, 2, 1, -6, 6, 7, 9, -1, 2, 0, 1. Oh, the sparkling water is awful. Interesting. Sorting's not going to help. I think we could make some sort of sum array. That seems useful to some degree. If we had some sum array like this is the actual array, and then we could have something like this, which would be the sum array, which would be something like this: 2, then 3, then -3. Alright, we have -3. -3 plus 6 gives you 3. 3 minus 7 would give you 10. I feel like I'm butchering this addition. Zero, 2. Yeah, I'm already messing. No. So now 0 plus 2 plus 1 gives you 3. Right, 3 plus negative. Right, I think I've already messed this up. 3 plus -6 gives you -3. -3 plus 6 gives you 3. 3 plus -7. 3 plus -7. 3 plus -7 gives you -4. Plus 9 gives you 5. Plus 1 gives you 6. Plus 2 gives you 8. So gives you nothing. Plus gives you 8 again. Plus 1 gives you 9. So I feel like this is wrong. So I'm going to double check. 0 plus 2 plus 1 equals 3 plus and check it with a calculator. 0 plus 2 plus -1 plus -6 plus 6 plus -7 plus 9 plus 1 plus 2 plus 0 plus 1 gives you 7 at the end, and somehow I have 9. So 0 to, oh no, wait, that should have been 1. It does equal 9. 0 plus 2 plus 1 plus -6 plus 6 plus -7 plus 9, 1, 2, 0, 1 does indeed give you 9. So how can we turn this into something that makes sense? We know that the ideal answer ends up splitting these up like so, ending at 1, and then 2, 0, 1. So at the time of that addition, right before it equals 3, so I think we could make this make sense. We know that the range of palatable answers is 0 to r dot length minus 2, right? So what if we start from index 0, and what we'll do is we'll iterate, right, all the way through this pre-computed sum array, and we'll subtract the sum, right, that we have in the sum array, or the prefix sum for 0. If it equals 0, we're good. Right? Which would make sense. Now the issue is we're not going to find one for 0. Alright, but let's just say we find the one that we're looking for, right? If you start at index 3, right, we know that 3 is a potential answer. We go through, right, we get up to 6, and then we say, okay, if we take the value 6 and subtract it from our first sum, or our base sum, right, then we can get 3, which is exactly what we're looking for. And then for our final third part sum, you can subtract 6 from it to get 3. So we know that we can get 3. The issue, though, is once you get that index, it's pretty much a 3-stage process where we're going to iterate through every number in the array. We're going to try and use every number up to r.length minus 2 as a starting point. And when we do, we're trying to find an index after that index, which we can subtract its sum array from to check if it equals the value at that sum array index. If it does, then we're good. We can drop into the third part, where we iterate over all the indices. Problem is that runtime would be n cubed, or would it? We check every pair of 3 numbers or 3 indices. That would be 9 factorial, which is impossible. I'm pretty sure the sum array is the solution. Maybe you can do it in n squared, but twice. The first one lets us help us find. Maybe we can do n squared twice. The first one will help us find the candidates. And the last one, find candidates for 3. Because in the first one, we want to try every number with every other pair, right, up to r.length minus 2. To see if there's any index in the sum array such that that sum array, that index minus the current index in the sum array equals the number at that index. If it does, then we'll add it to a potential candidate. We'll add that those two as a pair for candidates. Good part about this, it would just be n squared twice, because from then we just need to take those 2 pairs, and really just the second one, and see if there's any number after that index such that the number at that sum, the index of that sum array, the index of that element in the sum array minus the second index for part 2 equals the number itself. So I think that's what we'll do. We'll have candidates, which is going to be an array of numbers. But first what we need to do is create the sum array, which is going to look like this, and it's going to be an array of numbers. Then I'm going to make sure that we cut this out here. We're going to say I is equal to 0, I is less than r dot length, I plus plus. I say let sum equals 0. I say sum plus equal r sub I, sum array dot push sum. And I'm just gonna click run just to test that our sum makes sense, our sum array makes sense. I'm not even printing it, so that doesn't make any sense. test case am I looking at? Okay. I was going to say, because our numbers are way off. Yeah, so for our first one, we just have to find between the range here, right, is there any number that we can subtract our current sum array index from and get the number at that sum array. To do that, that's basically just going to be n squared time. Say let I equals 0, I is less than r dot length minus 2, I plus plus. If you can duplicate that, change it to m, and fortunately m is going to be equal to I plus 1 because it has to be after the index, otherwise this doesn't make any sense. So maybe it actually won't be I mean, it's going to be a little less than n squared, but basically it's squared, I think. You'll say I can't equal m, right, because it's going to be ahead. And then we're just going to say if sum array sub m minus sum array sub I equals sum array sub I, right, then what we want to do is say first and second candidates dot push, right, and we're going to have an array of triples here, and the values are going to be important because we're basically just going to say the first index is going to be what the actual goal value is, right, and that's going to be sum array sub m minus sum array sub I, and then we're just going to put the indexes, right, I and m into the triple. Then later on, right, we can now do a new for loop based on the secondary values. So now for const triple of first and second candidates let me make this smaller because I think I made this too big. So now, is this our usual size? No, I think it's usually bigger. From here, now we can just go over from the second index to the end of the array basically and see if, right, we can do for let I is equal to second index plus 1, right, I is less than r dot length I plus plus, and we'll say if, right, sum array, right, sub I minus sum array sub second index equals sum, we can return true. Otherwise we can return false. Wonder if we'll get TLE. So we return true. I'm trying to figure out why though, because our sum array looks like this. Can you break it up so that they all have the same sum? I don't think you can. One of these will end up with 2. One is end up with 1. So we have 2 and 1. There's just no way. So something not adding up here. 1, 1, 1. There's no way to break this up. So how are we ending up with this actually existing? Do sum erase of I. Well, I guess we should just print what the second candidates were. So the sum is 1. Oh, I think I see what the issue is. There shouldn't be the subtraction value. It should literally just be the value at sum erase of I. Well, I guess if we're adding it, it already equals the same value. Index 0 and 1. Right, so we have a sum of 1. Is there another number that you can I guess, yeah, you can subtract 3 from 2 and get 1. Somehow this one is failing me. Sum array. The index we have 3, which means that the number at that index is 1. I think I see what's happening. The remaining pair should include both the values here, but it doesn't. I think we needed some sort of visualization of the array in the second loop that is more accurate. That is actually accurate, because the sum here is not 1. It should be 2, because it should include all the elements at that index up until the end. But the way that the array is summed from front to back, there are missing elements. Maybe we should do it in reverse. If we did our sum array, if we created our sum array in reverse, I think we need to create the sum array, but in reverse. I'm not exactly certain why, but I feel like we have to. Technically, this unshift will be n squared, I think. Because for each element we add to the front, we have to shift all the elements forward. But I think now what we can do is if we do sum array 2 minus sum array sub second index, it equals the sum. I think we should be good. Something is at play here. We have 0, 2, 1. Wait a second, I just realized you can't check any other index other than the first because the first two parts of the array are set. The only thing you can check is if the sum that we currently have if sum equals with the second sum array 2 second index plus 1. That's the only thing you can check for. I just realized. I think it's gonna solve it, but I think it's gonna be really slow. So it looks like we're not finding any indices such that the sum array of m minus sum array of I equals sum array of I. So basically, there's nothing such that 30 minus 18 30 minus 18 does not equal 30. 30 minus 18 does not equal 18. 12 minus 18 does not equal 18. 30 minus 18. 12. Then we'd have -7, -8. What's the pair of 3 here that makes sense? You 12, 18. This would give you -6, -6. So 18 would give you 12. Maybe it's 12. And with -1 here, -2. Get 8, 18. Maybe it's just 18 by itself. Yeah, what's the 3 here that gives you... I'm not seeing the 3 numbers that sum up to something equaling with an equal sum. Yeah, we'll have to come back to this one. That's unfortunate. But hopefully we can fry this one tomorrow. But I have a good feeling.